In this application, we're going to look at the Acuity AP820-5 laser line sensor, and here you can see we've got it mounted on a little manual mechanical slide with a little encoder wheel built into it. And this laser's got a 5mm Z depth of field and approximately a 4mm to 5mm wide laser line length. We should have a resolution in Z of about plus or minus 3.5 microns linearity. And the X, of course, we're going to be closer to about 6 or 7 microns in the X direction. And what we've got mounted here you can see I've got a white ceramic Mitutoyo gauge block, and I've got it on a table. And what we're going to look at here is we're going to use this as a sort of a quick proof of concept and being able to make that measurement. So here you can see I've got some tools set up already. And this is the white ceramic gauge block. Here's the tabletop, and we've put these little measurements blocks in here, and we're taking the average of these blocks. And of course we can make that a little larger to increase that averaging over those pixels. And what we're going to look at is so that's a 1mm gauge block. And if we come in and look at that results screen, you can see that we're within, plus or minus 3 or 4 microns, as you can see, in accuracy. So that's just a quick proof of concept that we are making that measurement correctly. So let's go ahead and clear that, and let's take a look at our actual target. So this is the first target, and it does have a little bend into it. So let's see if we can sort of use this little bit of clay to help give more of a flat surface to measure it on. So we're just using that to hold down the surface. As you can see, we are making a good measurement on these surfaces. There aren't any spurious artifacts. And once again, here's the base material, and this is the black target surface that we're measuring. And of course, as I go over that, we can see how that changes. And there are some little areas here where you can see right there where I'm hitting the clay a little bit there, but you definitely can see that we're not having any problems making those measurements. So if we wanted to do the same feature measurement and we wanted to add new measurements, we would come in here. Feature number 2, we're going to measure the height. We also could do the width of that if we wanted to, and we're going to take the averages over that. And of course, on that screen, let's put in what we call a results screen. So that we can see it a little bit better. And so here you can see that we're getting a height of about 0.66. And of course you can see that changing a little bit. So it appears not to be very tightly controlled. But you can see we can easily make that height measurement, or we could come back in here and we could do a width for this surface here. And of course we picked the 2 further, and you can see here we're at about 1.7 millimeters in width. Let's go ahead and remove this also. And so let's also take a look at this in a 3D view. We'll change the settings and let's get rid of the grid. And so here you can see that we're scanning this, and we're using the little rotary encoder just to build that up. And here you can see we've got a little defect. And if we take a look at this, maybe we can adjust it with some of the color scales a little bit better. Maybe it gives a little more resolution. And we'll put this in static points. And so here you can see that right there's that little defect, but we have built up that 3D model of that part. And of course, you know, with better fixturing, it will produce a much cleaner result. But that gives you a quick feel for it. Let's see if we can highlight this a little bit. I'm not getting much color change on it to be able to see that difference. There we go. So that helps us see a little bit. And so we can also come in here and export it. So we disconnect it, we come in, and if we want to, we can export, we can save this as a .dat file, and what that does is it lets us come back in and open it up again. So we'll call this sample 1. And we can also come in and export this as a TXT file. Export as T or CSV, and we'll call this sample 1 also. So now we've been able to come in and save that data. And let's take a look at the next sample that appears to have been much better manufactured, as far as it seems to be a little more consistent. So let's come in here and let's clear this out. And let's take a look at this in 2D. And we need to connect again. I guess the profile doesn't look as good on this surface, so maybe this one seems to have a little bit more problems. And let's just validate this again with looking at our white ceramic gauge block. You can see that is really square and accurate. And so these surface readings we're getting on the part, I'd probably recommend maybe a little low pressure vacuum plate to hold that part down. But it appears to be giving us, definitely the traces do not look as clean as on the other surfaces. So let's go ahead and go back into 3D view, and let's take some more data here. And we'll go a little bit slower. We just need to zoom this back. We need to find that area again. So we just reset the camera. And so here's the 3D view on this what we'll call sample 2. And it seems to have a little bit more steps on it than the first sample. And let's come in and we're going to disconnect it, and we're going to save as sample 2 as a .dat file, and then we're going to export it once again as a TXT. And you can see that we have other methods to save it in. We can export this as a CSV, TXT, or a frame, a TXT frame. So just a quick example of how the AP820-red laser is making measurements on this target surface. Looks pretty good.